Hi guys, today's topic in chemistry would be structure and bonding. Now it's a good day today, so please look at it with optimism. We know that scientific revolution has happened in the past and it will happen in the future. So scientific revolution leads to safer and more effective medicine, cures for genetic diseases, increased lifespan, improved quality of life. Over millions of years, we have come so far to the stage we are today with this advanced technology. And the advancement in medicine and biology requires a deep understanding of organic chemistry. And that's exactly the reason why we need to study chemistry, and in particular, organic chemistry. On the left picture here, you see the very renowned scientist and philosopher Galileo Galilei showing the Doge of Venice on how to use their telescope. And on the right side, this shows the French Academy of Science, Académie des Sciences, 1698 taken, and they were established in early 1666. This is a snapshot of a molecule called statins, and is one of the very important biological molecules you have to know, because that molecule reduces the risk of coronary artery diseases by lowering the blood cholesterol levels. Very complex molecule, has many groups here, has many functional groups. And why is it so special? Because CAD, coronary artery diseases, is directly correlated with blood cholesterol levels, and about 75% of blood cholesterol, which is worth 1000 mg per day, is biosynthesized. So drugs such as this molecule called statins reduces the risk of CAD by lowering the blood cholesterol level. Now in 3-hydroxyl-3-methyl glutarate coenzyme A, in short we call it HMG-CoA, to the conversion of mevalonate. Now this is a crucial step in the biosynthesis of cholesterol. We know that cholesterol is good for the body, is also harmful. Too much of something is bad enough. So we need to control the amount of cholesterol in the body. And if it's too much, what do we do then? We apply a drug, atorvastatin, or the drug name is called Lipitor, and these inactivate the enzymes that catalyze this mevalonate conversion. So the question is, how does this atorvastatin control cholesterol biosynthesis? So the metabolic conversion of HMG-CoA to mevalonate is a crucial step in the body's pathway for biosynthesizing cholesterol, and X-ray crystal structure of the active site in the HMG-CoA reductase enzyme that catalyzes the reaction is shown alongside with the molecule of the Lipitor that's bound to the active site, right, and stops the enzyme from functioning. So with the enzyme being inactivated, cholesterol biosynthesis is prevented. Now in organic chemistry, all organic compounds should contain the element carbon. Carbon comes from group 4 in the periodic table, so it should share 4 electrons, and it forms 4 strong covalent bonds with the neighboring elements. Now it bonds to other carbon to create chains and rings. Benzene rings, polymers in your plastics, our skin, hair. But take note that not all carbon compounds are derived from living organisms. Over 99% of the 37 million known compounds contains carbon. And here you see a picture of the carbonary. When you say about carbonary, you might think, it sounds like what? Something that you eat in the restaurant. That's right, it's carbonara. So these two are actually linked. Carbonara is a food, right, in the pasta. So it used to be eaten, the staple meal of these workers whose job profession is called carbonari. So Italian stands for charcoal maker, carbonari or burners. So these were the group of secret revolutionary societies that were active in Italy during the first 3 decades of the 19th century. So now we know where does the term carbonara is from. Right? Contains a lot of carbo, but it came from the staple meal of carbonari. Now this figure here shows the elements commonly found in organic compounds, those that are shaded in colored. So carbon, hydrogen, and other elements are commonly found in organic compounds. Show there are carbon, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, sulfur, phosphorus, and hydrogen. Now this figure here shows the dense, positively charged nucleus that contains most of the atom's mass, which is mainly protons and neutrons, and it is surrounded by negatively charged electrons. So the three-dimensional view over here shows calculated electron density surface. Now electron density increases steadily towards the nucleus because the nucleus is positively charged, so it attracts the negatively charged electrons, and this is 40 times greater in the blue solid surface than the gray mesh surface. So you see all around this sphere it is electrons regions where you can most probably find electrons, but in the blue zone you can find electrons most frequently. So you see, normally you see this kind of orbital structure. Now the structure of the atom consists of mainly the nucleus, which is positively charged. Right. It is very small, 10 to the power of negative 14 to 10 to the power of negative 15 in diameter, very tiny. It contains essentially all the mass of the atoms. And the second part of the structure of the atom will be the electron cloud. But because they are so massless, each electron is about 1/1680 times of that of a proton and neutron. So essentially all the mass of the atom will be the mass of the nucleus. An angstrom is 10 power negative 10 meters, or you can convert it into 100 picometer. Now these are the terms that you have to know them very well as scientists, not only chemists. Atomic number normally represented by the symbol Z. You see this box here in every square in the periodic table. Now do not be deceived by the position of these numbers here. You just need to recognize two things. One is the big number, one is a smaller number. The bigger number must be the mass number, which we denote with A, and the smaller number here will be the atomic number that's always an integer. Now we have the symbol that represents the particular element and the name that spells it in English. Now isotopes are atoms of the same element with different number of neutrons. We do not have to specify that they have the same number of electrons, because when the term says atoms means they are neutral, no charge. No charge means they have the same number of protons and electrons. Now what is atomic mass, or some people call it atomic weight? And this is the weighted average mass of the atomic mass units, in short AMU, of an element's naturally occurring isotope. So there's a slight difference between atomic mass and the mass number. Because mass number must be a whole number, it is the sum of the protons and neutrons, and you can't cut a bit of a neutrons or protons. So mass number must be a whole number, but the atomic mass can be of a decimal places because of the average, sum of the average of the ratio of the isotopes that element has. You got to learn these structures well. S orbital is defined as a sphere. P orbital, we have two lobes, like a dumbbell shape, right? But the true shape here is more like a doorknob, if you can imagine a doorknob. And for D orbital, it is a cloverleaf shape. So think of it as two dumbbells intersecting each other diagonally.